very similar to the lunch order bean, except it's using telescoping constructors. So if we look at the constructors in this class, I've got a lunch order tele here. If I set these two side by side, you can see that they're very similar in nature to one another, except that we have a bean model, which is a no arguments constructor with setters and getters, versus a constructor model, which is building upon the constructor for each individual case that we want to work with. Now, let's move this back over here and look at this in a little bit greater detail. You can see that our constructors build upon one another. So we have one that takes the bread, one that takes the bread and condiments, one that takes bread, condiments, and dressing, then one that takes bread, condiments, dressing, and meat. And I've telescoped one way with this. I've gone up. You could go down. So what I mean by that is we have this bread, condiments, and dressing, which is calling this constructor, which in turn calls this constructor, which in turn calls this constructor. So they loop or recurse through each one. The bad part of this is, well, we could also go the opposite way, which can be a little confusing. I could call this and pass in null to the other ones or some default value and work our way down all four of these constructors. But what happens if I want to build a sandwich that I don't want bread or I don't want condiments? I just want bread and meat. Or maybe I'm on the paleo diet or Atkins diet and I want to do condiments. I just want lettuce wrapped around meat and I don't want any dressing. I don't want anything else. Well, this example won't do this. So I have to add another constructor just for that. So I could do a constructor that is bread or condiments and meat, or just condiments or condiments, meat, or straight meat, which it doesn't lend itself very well to that. Now, the bean demo does do that a little bit better, but then we have getters and setters for everything, and it's immutable after the case. So this example is immutable. So I can have it one way or the other. I can have an immutable example using the telescopic constructors, or I can have one that will work for all the configurations that I have, which is the bean model. So you can see the drawback to both of them. And just to show you how this runs, I've got a constructor here that takes wheat, lettuce, mustard, and ham. If I go ahead and run this example, you'll see that it prints out what we're expecting here. But I've left in these setters to show you what we would have to do to get the configurability we want from the bean example. And we can't do that. If I uncomment this, it's going to tell us that's not available because that setter doesn't exist. So this is one of the problems with the telescoping constructor method versus the bean. Now the next example is going to be using the builder, which is the best of both worlds in this case. And you can see how it's a little bit more configurable doing these types of things here for our lunch order that is very similar to what we had for our lunch order bean and our lunch order telescoping constructor model, except there's a few little changes in here. To start with, I've got this string bread, condiments, dressing, and meat, and then we've got the skeleton of a public static class called builder inside of here. Now, inside of this, we're going to actually implement this builder and show you how this works. It's a little different, so I didn't want to use any copy and paste code in here. First, we want to go through, and this seems a little redundant, but we're going to create the same fields that we have inside of our lunch order class. So we're going to do private string bread, we're going to do private string condiments, and then we're going to do dressing and meat. The purpose for this is that the builder is its own container until we tell it to finally make what our lunch order is. So now that we have our bread, condiments, dressing, and meat in here, we start off first with a basic no-args constructor because we don't have any qualifications about what we might want to have inside of our sandwich. Now, the beauty of this is that we can mandate that this constructor take arguments for things that are required. So if we required everybody to have a bread and a meat associated, we could make this constructor force that, but we don't care about that. So from here, let's go ahead and we're going to create a bunch of methods that are going to look like constructors, but they're not. And this is the key to the builder pattern. Let's go ahead and make this full screen while we're doing the rest of this example. So we're going to do public builder. It's going to return an instance of itself. And this one's going to be for bread. I'm going to say string bread. Now the beauty of this is that we could also use type-safe enums for this as well. So say this.bread is equal to bread. Now the catch here is that we return an instance of this. And by this, we mean the builder object, this object that we're creating. Now, that seems a little weird. It's so you can do a little approach or technique here that I'm going to demonstrate in a minute about using the return to build out your object. So let's finish this out for the others. We're going to do the same for our condiments. And rather than type everything out, I'll just copy this and paste it in so you can see it. So we're going to paste in our condiments, dressing, and meat. So now all of these are the same. We have an instance of a method for bread that returns an instance of builder, an instance of itself. And then we're going to do one last key part, and that's implement the actual builder. Now to do that, we're going to do a method called, we're going to create a method called public lunch order that returns, public lunch order. And it has a method in here called build. Now this is a little different than the others because this is going to return a new lunch order using this. Okay, so this has inside of our lunch order object, we have a constructor that takes a builder, and then that copies over the bread, condiments, dressing, or meat that we have created, and we can enforce the contract inside of our builder. But also notice that there's only getters down here. I've minimized them so it doesn't take up as much space. There's only getters, so there's no setters. Now the beauty of this is we have the flexibility of the bean approach with the contract nature of the constructors. So if we look at our build lunch order demo, our builder lunch order demo, you can see that what we did is created our new instance using the static inner class here. So we say lunch order.builder returns an instance of lunch order.builder, and we have our builder object. Now from here we can say builder.bread, wheat.condiments.dressing.meat. That's why we return an instance of ourselves, so we can just tack on these methods as we go and build out our object. Now, why I like this and why this solved the particular problem that I was looking at here with this lunch order problem is that I was parsing these values out of a CSV file, out of a comma separated value file as I was going. So instead of trying to gather all those at once and all the different conditions, I could grab it, and if that value existed, I could then append it on. And if it didn't, I'd go to the next one. So if somebody had bread, no condiments, and mayo and turkey, great. If somebody just had bread and meat, great. I could keep going through. I don't have to have this in here. So I can cut one of these out and it will work just fine. So if we run this, you can then see that the next thing we do after we have all of our builder condiments and everything else added on there, we call build. If you wanted to, you could name this method make me a sandwich. We call build, and it returns an instance of our lunch order, but we also have that immutability that nobody can edit it. So now if we run this, we can see there is our wheat, lettuce, mayo, and turkey, but we can also chop out one of these and it'll work just fine, and we don't have to have an edge case constructor for it. We don't have to worry about the bean method immutability or whether or not. Now notice this value is null. We could also set a default type in there, the empty string or whatever we want to do. So we get a lot more flexibility about the creation of our object and how to handle these types of things. And like I said, just to reiterate, if you did want to force them to have certain things in there, we can make it to where they have to use one instance of the builder with whatever those values are. So we can get that benefit of the telescoping constructors without the limitations or the problems of maintaining those individual constructors.